Okay, so lesson number 3 continues on what we did yesterday with converting from an entire radical to a mixed radical or a mixed radical to an entire. Only this time we're not just looking at square roots. We're looking at cubed roots or fourth roots or fifth roots and looking at that process. So, like a square root, when we were trying to convert an entire square root radical into a mixed square root radical, we had our list of perfect squares that we were looking at. If my index is a 3, or if it's a cubed root, now what I have to consider is my list of cubed or perfect cubed numbers. So 1, 8, 27, 64. So if I have a number like 54, and I'm trying to change the cubed root of 54 into a mixed radical, what I look for is, can I divide 54 by one of these numbers, by one of these perfect cubed numbers? And the answer is yes. I can divide it by 27. And I get 27 times 2. So then I can separate this to be the cubed root of 27 times the cubed root of 2. This is the step that I generally don't actually show. The cubed root of 27 is going to be equal to 3. So this becomes 3 times the cubed root of 2. So then I can say that the cubed root of 54 equals 3 times the cubed root of 2. And again, the thing to remember is this 3 has to be shown smaller, almost like an exponent fitting into that checked part of my radical symbol. Okay, so if I look at class example number 1, A and C are both cubed roots, so we can use our list of perfect cubes. For B, we're going to do that one a little bit different because it's a fifth root. So, first of all, let's look at the cubed root of 6,000. According to this chart that you have here on your page, what number could I divide 6,000 by? 1,000. So I would get the cubed root 1,000 times what? 6. Okay. I generally put my perfect cube number first. What is the cubed root of 1,000? 10. So I get 10 times the cubed root of 6. The only other thing that I should check is, could I divide 6 by one of those perfect cube numbers? I want to make sure that 6 is the simplest radical that I could have. And it is. Okay, so let's look at 3. Or sorry, C. Can I divide negative 16 by a perfect cube number? 8. Should it be negative 8 times 2, or should it be 8 times negative 2? Does the negative matter? Does it matter which one it's with? Probably not. Can I find the cubed root of negative 8? What would it be? Negative 2. So I could have this as being negative 2 times the cubed root of 2, or I could have had 8 times negative 2, in which this would have been 2 times the cubed root of negative 2. Either answer would be acceptable, although generally if we can pull the negative from outside the radical sign, we would. Okay, so that leaves us with B. If you have an index that is more than 3, because perfect square numbers and perfect cube numbers we should be able to get a handle on, but trying to find perfect numbers to the power of 4 to the power of 5 starts to become a little bit harder. So what we're going to actually do is we're going to go back to prime factorization. So if I think of the number 320, if I divide 320 by 2, because I know 2 is a prime number, so we're going to start with our 2's. Divide 320 by 2, what do I get? 160. Can I divide 160 by 2? What do I get? Can I divide 80 by 2? What do I get? 40. Can I divide 40 by 2? What do I get?
20.
Can I divide 20 by 2?
Yeah.
What do I get?
10.
Can I divide 10 by 2?
Yeah.
What do I get?
5.
And can I divide 5 by, I can't divide it by 2, but what can I divide it by? 5. This is the prime factorization for 320. 5 times 2 is 10, 20, 40, 80, 160, 320. And this is the 5th root. So if it's the 5th root, I need a number that I can multiply by itself 5 times. That's the number that I'm multiplying it by itself 5 times. So the 5th root would be taking the 2 out. And then leaving me with whatever is inside. Or whatever is left. This 2 and the 5. So then I get 2 times the 5th root of 10. Okay. You're not going to see a lot of these questions. I might throw one at you during the course of the entire semester. Most of the time we're going to deal with cubed roots and square roots. But if you did have something that was the 4th root or the 5th root or even the 6th root, bring it to its prime factorization, and then you were looking for the same number of factors as what this index is. So if the index was 6, I could still take that 2 out because I have 6 of those 2's being multiplied. What is 2 times 2? 4 times 2? 8 times 2? 16 times 2? 32. And if I found the 5th root of 32, my answer would be 2. Okay? So if I go backwards, going from a mixed radical to an entire radical, when we did our square roots, when we wanted to put the number back underneath the radical sign, I had to square it. If I want to take a number and put it under the cubed root sign, I would have to cube it. So I would take my 1/2 and I would cube it. So if I take 1/2 and if I raise it to the power of 3, raise both of these to the power of 3. So 1 to the power of 3 is 3. 2 to the power of 3, 8. So I get the cubed root of 1/8 times 80. And if I didn't use a calculator for this, 8 is on the top, 8 is on the bottom. So think of it as division. 80 divided by 8, 10. So the 1/2 times the cubed root of 80 would be the same thing as the cubed root of 10. Okay, so we have a couple of examples on the next page. So I'm going to look at B and C first, and then we'll do A and D afterwards. So if I look at B, so I want to take this -4 and put it inside the radical. I would take the -4 and I can cube it. Why can I put the negative inside the radical this time? Because yesterday we didn't.
Because you're going to get a negative.
Because I can actually take the cubed root of a negative number. So -4 to the power of 3 times 7 equals what? If you didn't put the negative inside, you could get this. And I would still mark it correct. So the negative could be inside or it could be outside. If I look at C, it is 2/5 times the cubed root of 100. So when I put the 2/5 underneath, I would cube it and then multiply it by 100. And tell me what you would get. So if I put this in my calculator, or not, so 2/5 I would put in brackets to the power of 3 and then multiply it by 100. Oops. Okay. Multiplied by 100. I get 6.4, but if I wanted to keep it as a fraction, 32/5. So the cubed root of 32/5. If we look at A, it's a 4th root. So when I put the 2 underneath the radical sign, I would raise it to the power of 4. So then on my calculator, it would be 2 to the power of 4. And to get that, 2, and then there's my power button, to the power of 4 times 3, and I would get 48. So I'd have the 4th root of 48. With D, if I put the number underneath the radical sign, do I put the negative under there as well?
No,
Why not?
because it will become positive.
This is an even index, so the negative has to stay on the outside. And it's just the 3 that I would put inside. So then 3 to the power of 4 times 2 would equal, Delana, I'll wait for you to do that and then you can tell me the answer.
Because you go like this, times that, and it's like
What'd you get?
Yes.
Okay.
7.6. One, yeah, in your app, 7.6.
Don't put the radical symbol in there, Delana. Just 3 to the power of 4 times 2. So I'd have negative 4th root of 162. But it is going to be useful. And it is looking at variables. So if I have x to the power of 6, x to the power of 6 is x times x times x times x times x 6 times. Or 2 groups of x times x to the power of 3. My exponent rules from last year, which you guys did in grade 9, if the bases are the same and I'm multiplying, I can add the exponents. So square root has an index of what? 2. When I'm calculating the square root, what I'm basically doing is asking what number times itself would give me x to the power of 6. Well, that would be x to the power of 3. 2x to the power of 3's would give me x to the power of 6. If I'm finding a cube root, then what I'm looking for is a number that when I multiply it by itself 3 times, I get that value. So x to the power of 15, I can look at it as being an x to the power of 5 times an x to the power of 5 times an x to the power of 5. So when I take the cubed root of it, I would get x to the power of 5. What do you notice about these two, or these three numbers? The 3, the 15, and 5. The 2, the 6, and the 3.
You divide the power by the index.
If I divide the power by the index, I'm going to get the exponent on my answer. So if I wanted to take the square root of x to the power of 4, what would I get?
X to the power 2.
If I wanted to take the square root of y to the power of 10, what would I get?
Y to the power of 5.
Thanks, Connor. If I wanted to take a to the power of 8, b to the power of 6, and I wanted to take the square root of that,
A to the power of 4.
4 and b to the power of 6. 3.
what about the cubed root of x to the power of 24?
X to the power 8.
It'd be
And the cubed root of y to the power of 6?
Y to the power of 2.
So then the next part, what happens if I can't divide it evenly? Because if I have x to the power of 5, 5 divided by 2 isn't an even number. Split it. I know that if it's a 2, I can divide any even number by 2. So I make this a 4 times x. X to the power of 4 times x is still going to give me x to the power of 5. But now I have the square root of x to the power of 4. What is the square root of x to the power of 4?
X to the power 2.
And then I'll still have this x underneath the radical sign. So I can say that x to the power of 5 is the same thing as x squared times the square root of x. So if I have the square root of a to the power of 7,
a to the power of 3.
okay, so how did you get the 3 first? What did you do underneath the radical sign?
I split it.
To 6 and a.
Okay.
So then the square root of a to the power of 6?
It'd be a to the power of 3 times square root of
Right. So how would I split t to the power of 9?
T to the power of 8.
T to the power of 8 times t to the power of 1. I can use a dot for my multiplication symbol instead of an x. So what is the square root of t to the power of 8?
T to the power 4.
So I get t to the power of 4 times the square root of t. Okay, c is a bit different because I have a cubed root. So if I have a cubed root, how would I split x to the power of 5 up?
X to the power 3 is x to the power 2.
Because 3 I can divide by 3. So what would the cubed root of x to the power of 3 equal?
X times root x squared.
Root 3x squared.
2x.
So do you times that?
Or the cubed root.
Third. Whatever.
Yeah.
I knew what you meant.
That answer.
It's perfect.
Okay. What would I do if it was x to the power of 7?
X to the power 6.
the cubed root of
So I'd have x to the power of 6 because I can divide 6 by 3. And then the other x to give me to 7. And the cubed root of x to the power of 6. Kirsten, what would I do with the power and the index? And then the cubed root of x. So the next two sets of examples, the questions just become more. We increase the number of variables. We throw numbers in there as well. We just get crazy. So if I x to the power of 6 and y to the power of 5.
Oh.
This is an index of 2, so I have to be able to divide everything by 2. Can I divide 5 by 2? No, what can I divide by 2? 4. So I change the y to a 4 and a 1. What is the square root of x to the power of 6?
X to the power of 3.
Kate, what would be the square root of y to the power of 4? And then the y that is remaining would stay underneath the radical sign because I can't square root just the y. Okay, in B, I have numbers and I have variables. So let's look at the number first. This is a square root. So can you think of a perfect square number, which are that column that's in the reds? Can you think of a number that I can divide evenly into 18? So I get 9 times 2. And then what do I need to do with my x cubes? I have to split it into x squared and x. And then I go through. Can I take the square root of 9? I get 3. Square root of x squared, I get x. And then I'm left with a 2x. The next one, 32. What perfect square number can I divide 32 by? 16. So 16 times 2. And then y to the power of 7 I have to split up into y to the power of 6, y to the power of 1, and then my z to the power of 8 I can leave. Because I'll be able to divide that by 2. So square root of 16. And the 2 is going to stay underneath the radical sign. Square root of y to the power of 6. Y to the power of 3. This y is going to stay underneath. And the square root of z to the power of 8. Z to the power of 4. Okay. D is an index of 3. So with 40, I have to think of a perfect cubed number. What can I divide 40 by? 8. So I get 8 times 5. X to the power of 4, I would split into 3 and 1. So x to the power of 3 and x. And do I need to split y to the power of 9? No, because I can divide 9 by 3. So the cubed root of 8 is 2. And then I'm going to put my cubed root over here because I can put the 5 underneath. Cubed root of x cubed. X to the power of 1. And then this x will stay underneath because I can't cube root that. Can I cube root y to the power of 9?
Y to the power of 3. I leave that out.
So I get 2xy cubed times the cubed root of 5x. So the last 4 go from a mixed to an entire. So that's putting everything underneath the radical sign. So if I have to put the 2 underneath the radical sign, what will I need to do to it? I need to square it. So what is 2 squared? So I will get 4x cubed, the square root of 4x cubed. If I look at B, To put that a squared underneath the radical sign, I have to square it. So if I have a squared raised to the power of 2,
It's actually a to the power of 4.
it's a to the power of 4. And then if I times that by a, what do I get?
Power of 5.
A to the power of 5. For C, the same thing. If I put x to the power of 5 underneath the radical sign, I need to square it. And what is x to the power of 5 squared? Not 7. 10, because it would mean 2 groups of x to the power of 5, right?
So you're just multiplying the.
We just multiply.
Yeah, when there's brackets and you have
Just
this going
multiply
on
it
either
by
side,
2.
you multiply them by 2.
Yes. So this you multiply, and your question was,
I was just getting confused because you were saying square and then you're.
well, it's x to the power of 5
Yeah.
squared.
Yeah, that,
which
I was
means-
just getting confused.
Multiply x to the power of 5 by itself twice. So how many x, or, sorry, not how many
X.
x's, x to the power of 11 times y.
But isn't xy like one thing?
Nope, because xy is x times y.
So
I can
2
split them
times
apart.
2.
Because x and y would be 2 different values. What do I have to do with d? I have to take this 3xy cubed and I have to cube it. And then I have to multiply the answer by 2z to the power of 4. Three to the power of 3.
Like that.
27. X raised to the power of 3 would become x cubed. Y raised to the, or sorry, y cubed raised to the power of 3 would become
By 9.
y to the power of 9 times 2z to the power of 4. Is there anything else I can multiply together in this statement?
The 2 and 27?
And what would I get?
54.
54. And then the variables, I generally put in alphabetical order.
Those pencils.
So the questions, 1A and H, 2B and D, 5 and 6, 8, A, F, and H, 9A, 10A and C, and then 11.